So welcome, we are on day 3, so class 3, talking about data structures, and we are actually talking about module 2, which is going to take us a deep dive into lists, where we're going to learn about indexing into lists, slices, which is a partial piece of a list, and some of the other methods that we can use with the Python built-in data structure Python list. With that, we're going to go ahead and jump into our Jupyter Lab. We're on our day 3 notebook, and we're on the indexing, slicing, and list methods section. I've got 5 areas I'd like to talk about. Standard indexing into a list, slicing into a list, getting a partial piece of a list, adding items to a list, removing items from a list, and then my favorite is list comprehensions. This is something you don't see in many other programming languages, but it really does make list very powerful inside Python and what we can do with them. Then I've got 2 challenges for us. One is to create a shopping list organizer. The other one is a very simple list comprehension where we're just going to calculate squares of numbers and write them in a generated list using numbers 1 to 10. So with that, let's go ahead and go back up to talking about indexing into list. The one thing I want to remind you of is list always start and end with the square bracket. That's how we know that it's a list. So in this case, I've got a list and I've got 4 items in it. And we index starting at 0. So we have 0, first item, second item, and third item. So if I want to grab the list, my list, and I want to grab the second item in it, I'm actually going to end up with 30 because it goes 0, 1, 2. And we'll go ahead and print that out. And we'll see how that works, and you'll see that we get the value of 30. It is zero-based, we got it there, and it also has an ability to go backwards through a list. So I could go -1, and that's going to go backwards through the list and start at the right-hand side of the list and say 40 is the -1 item. I could go all the way back to -3. You can see that's a 20, so -4 is the number 10. And that's going backwards through the list there. If I go outside the bounds, if I go -5, you'll see I'll get an error. The same is true as if I go forward through the list too far. For instance, since it's zero-based, I go 0, 1, 2, 3, so 4 is actually outside the bound. So I have to between -4 and 3 are the valid ranges that I can put in here. So let's go put the number 3 in here and show you how that works. Let me go ahead and run that again too. Oops, I don't know what I did wrong here. Oh, put some pound signs in there, I guess. There we go. Okay, so that's really what I want to teach you about lists with indexing into them. We've already seen that this defines a list. This is the same character, but we're using it in a totally different context. We're indexing into an iterable object. So when I'm creating something, I'm using the square brackets to indicate that it's a list. When I'm using the square brackets in this term, I'm actually indicating that I want to index into some item that's a list of items. Okay, so that's indexing. Slicing is a fun idea as well. We're going to take partial piece of a list. Let's create my list again. But this time, we're going to use the list constructor, which takes the parentheses, and then inside the constructor, I'm going to use our range method. And we said range, and we learned it a couple of days ago. It has the start index, then we do comma. We have an ending index, but it's actually 1 minus the end. So let's do 100, which means I'm going to go from 0 to 99, and I'm going to do it in steps of 1. So if I do that, and then I can print my list. Oops, what did I do here? Oh, I forgot to do the assignment operator. So I'm going to assign this to the variable myList. There we go. So now you can see that we're going from 0 to 99. And that's because we used the range thing, which gave us items 0 through 99. And then I put it into a list by using the constructor. So you'll see it starts with a square bracket, ends with a square bracket. Now what a slice does is it gives us a piece of the list. So I'm going to index, instead of indexing in and saying, hey, I want the 45th item, what I can say is I want the 45th item, but I also want to go to the 60th item, and it'll give me a piece of that inner bigger list, right? So it goes from 45, because that's where I sliced in at, up to 59, which I want to point out is it includes the first index, but does not include the last index. It's 1 minus the last. Again, the reason why we do that is if I calculate the length of this, we'll use the len function to calculate length. Oops. And you'll see that it's 15. So the length of our array is 15. And how do we get that? Looking at this right here, I can say 60 minus 45 is 15. So if I included the 60, then I would actually have 16 items, and so I can't use that kind of math. So that's why we choose to be inclusive of the first, include that one, but exclusive of the last. We always go 1 minus the last item. Okay, so I can run that now, and you can see how I can do a slice. Now I can also add another slice in there, and so I can do, I don't know, we'll go by twos. And you'll now see that I start at 45, like I said, 45, but I don't go to the next item, I count by twos. So now I go to 47, then I go to 49, and I go all the way up to 1 minus that value, so that's why I get up to 59. So slicing uses colons, and it always has the start index first, the ending index plus 1, so really I end at 59, and then our step size. It's very similar to our range, which does the same thing, but it uses commas. So it starts at 0, goes to 100 in steps of 1. What if I wanted to go in steps of 5? Let's get rid of our slice here altogether, just so we can see what we're printing out here. So range, I'm going to go from 0 to 100, counting by 5s. Now I want to slice into my list. I want to go from -1 to -7, going by -1. And there it goes. It starts at the end, counting backwards by 5s, giving me 6 items, because that's 7 minus 1, or -7 minus 1, which is 6. 1, 2, 3, 4, 5, and 6 items. And that's because I went by steps of -1. I could go steps of -2, and that'll give me 3 items, because it can't give me that last item. So it gives me 1 minus that last item. So I can slice forwards, I can slice backwards. I just have to make sure that I'm within the bounds of what's available. So in this case, I'm going, there's 100 items, but I'm counting by 5s, so there's actually 20 items. So instead of having, let's see here, we can go this way. So if I want to index and get the 20th item, that's going to cause a crash. Now I can get the 19th item, right? Which is actually the end, because I go from 0 to the end. So what I could do is I could say I want to go from 1, actually we can go, let's go from 5 to 19, we'll do 19 by steps of 1, and that'll give us, starting at 25, giving us all the way up to 90. All right, so that's what I wanted to teach you for slicing. It's a nice way to kind of take a sub-piece of our list. Say if we have 100 people, we could say, hey, give us the first 10 and assign that to Johnny to deal with. Give the next 10, assign that to Sammy to deal with. And you can break this big list up into manageable pieces and give it off to different people if their task is, I don't know, we'll say their task is to call people or to send them in a queue for grocery orders, whatever you want to do. You can slice the list up and hand it out to different people in sections. Slicing has all kinds of really good use, and I can slice forwards, I can slice backwards, however I want to slice. Okay, I keep talking about how awesome lists are, and that you can put any object you want in them, so it doesn't have to just be integers, it can be any object that's Python. So I could put in list inside of a list. I can put tuples inside of a list. I can put dictionaries inside of a list. But one thing I can also do, because lists can be changed, is I can add to a list. So let's create my list again. And we'll use our list constructor. So I'll say equals list. And I'll give it a string this time. This is a string converted to a list. Print okay, so what if I wanted just the word this? I could say, okay, well, let's just do a quick slice. I'm going to say 0, 0, 1, 2, 3. So let's go to 4. And I can just print the word this as a list. So that's slicing real quick. Now, what if I wanted to add something to the end of my list? I can use the append keyword, and I can put something at the end. Let's do exclamation point. I don't need to print that because that's doing a modification of the list. I want to print out the entire list. There we go. So I've got my list, and I'm going to get rid of the period here. So this is a string converted to a list. I'm going to append something to the end of the list, and then I'm going to go ahead and print it out. There you go. And now I can also print it out as a single word, because we can, or as a single string, because we can also do looping on list. If you remember how we do that, we did a for loop, because it's a defined number of items. So we do for each character in my list, I'm going to print the character, but I'm also going to do another trick that you don't necessarily need to understand this, but what I'm doing here is usually the print character does a new line, so it doesn't enter after every time it does a print call. I'm telling it to not do that new line here. So go ahead and print that. So you'll see that this is the list printed out, and this is us converting it back into a string on the there. So you can see I can add things, and when we get to the example below, the challenge question, we can think of it as a shopping cart. We can add items to a shopping cart or a shopping list, and I can, after I pick them up off the shelf, I can remove it from my shopping list. So we'll see how we can add things now with the append. Now we're going to see how we can do things removing them with the remove keyword, which is a method that's attached to the list object. So let's take this whole concept here, copy this and paste it down here. Oops, I didn't get the whole thing. Let me go back here and get this. Control C, Control V. There we go. Okay, so I have my string. Instead of, maybe I did have a period there, and I want to change it to be an exclamation point. So what I could do is I could say my list dot remove, and then I could say period, and it's going to remove the period from the end of this sentence, and then it's going to append it with the exclamation part. So let's go ahead and see how that looks. And you'll notice that as the list, it does not have the period because I removed it, and then I put in its place the exclamation point. So how did I know that the myList object, which is of type list, how did I know it had this command called remove or this method called append? Well, what's really neat about integrated development environments is the ability to use IntelliSense. If I hit the period button and then the keyboard tab button, there we go, where's my tab? There you go. It'll show me everything that's associated with list. All the methods or all the functions, calls them functions here, that I can do with a list. I can remove it, I can reverse, I can sort a list. So let's see how some of these work out. Let's create a new code block here, new section to write code. Let's create another MyList. This time we're going to do some random numbers in a list. So commas. Why am I not doing commas? There we go. So just some random numbers. And remember, lists are in insertion order. So I inserted 2 first, then I inserted 6, 2. So if I print this list, it should, and it will, print in the order that it shows it there, right? So it's going to print it in the exact same order you see up here is the same order you're going to print down here. What if I wanted to sort it and do it in numerical order? Oops, I meant to sort the list and then print it. Sort. There we go. So if you look at the numbers now, well, after I've sorted it and printed it, they're now in ascending order. What if I wanted to, well, this is kind of a, when we get to list comprehensions, I'll show you how I could reverse sort this. I think there's actually, is there a reverse method? There might even be a reverse method. Let's find out. Hit the tab button and look for reverse. There we go. So now when I print it, it's going to print it in descending order. So it starts at the highest number and then gets smaller. So if you don't know what object, what methods you have associated with an object, you can always use that IntelliSense where you just put the period and then hit the tab button and it'll show you all that is associated with the list. Okay, let's talk about list comprehensions now. List comprehensions is a very human, well, it's not very human readable, but it's a readable way of understanding what would take like 4 or 5 lines of code to write. You can write it efficiently in 1 line of code and have it kind of make sense. So let me break it down for you. We have it in square brackets. So what data type do we think that's going to be? Yep, that's going to be a list. And then it's got 3 components in here. We have some expression. We have some variable. And then we have some iterable object, some object that we can iterate over. It could be a string, it could be a list, it can be a tuple, it could even be a dictionary. Anything that we can iterate object or piece by piece of the item, we can do it this way. So the way it works is, the first thing is the expression. This is what's going to actually be executed. The second thing is we're going to define a variable name. In this case, we define the variable name x, and you'll see we're going to use x in the expression. And then we have the iterable object called range. So if I copy this, you'll see what I've got here. Copy. Oops, I keep right-clicking. I forget you can't right-click here. Control-C, Control-V. And then we're going to go ahead and assign it to some list, my list. And then I will go ahead and print that out. And so you'll see that we were having numbers in the range of, in fact, if I print this out, let's print that out first. So this object here is the range object that I converted to a list, and it goes 0, 1, 2, 3, 4. I took the square of each item because that's what the expression does. It squared every item in there. So 0 squared is 0. 1 squared is 2, 4, 6, and 8. So that's how that works there, right? So the first thing is the expression, what we're trying to do. It's not squaring. I'm sorry, I was thinking square. It's multiplies. That's why I was, 1 squared is not 2, but it's actually multiplying it by 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 6 times 2 is 8. All right, so that makes more sense. But it's what we could do if I wanted to do this. In fact, let's create another block of code and do this the way you probably see this done in other programming languages. Why is my mouse clicking crazy? Okay. So first thing we need to do is do a for loop, because that's how we do iterations on things, right? So I'm going to say for item in my range of 5. Then what I want to do, actually I've got to create my list, and we're going to make it an empty list. Then I'm going to say my list dot append, and instead of appending the item, I'm going to append the item times 2. Then at the whole end of the thing, I will print out my list. Okay, so what I did in one line of code here takes me 3 lines of code on the block here, right? So why does it keep, I'm clicking with my left mouse button. I don't know why it's doing that. So anyways, that's kind of distracting for me, but what it's doing here using comprehensions is the equivalent of doing it with these 3 lines of code. Much more readable, right? I can say, okay, what am I doing? My expression is multiplying every item in the list by 2. I give it some variable name x, and then I give it the items that I want to iterate over. So in this case, range of 5. Now this variable x is something that I can define. I could call it, instead of x, I could say item, and then I just reference it here as item and run it, and it's the exact same thing. I could call this test. It really doesn't matter. It's just a variable name, right? There's no trick to what we call that variable name, but it is just a variable name. It's just got to be the same here as it is in your expression, because you're defining the variable here, you're utilizing it in the expression here. Okay, so that's comprehensions, and it's very powerful because I can do lots of cool stuff, right? I could say, let's do another block of code here. We'll do for I in, we'll call it ones. I think there's one called ones. Is there? No, it's called zeros. I don't think it's called that either. Okay, we'll just do our range. Range of, we'll do 100. I'll do my colon, my indentation, and I'm going to append to my list. I'm going to append my I. Let me create my list above the loop to zero it out. Equals empty list. So what if my goal is to create a list that has 100 zeros in it? Because maybe I'm just going to zeroize something out. Well, in this case, I've got 0 through 99, but it's because I'm inputting in the value there. What if I just put a 0 here? And so that is giving me my 100 zeros, starting at 0, going to 99, but every time I'm appending the value of 0. I can do the same thing with list comprehensions in one line of code. So I'm going to print 0, oops, not O, 0 in whatever name I want to call it, item. That's going to be my variable name. Sorry, it's not, it's 4. In range of 100. And that gives me the exact same result as these 4 lines of code. So that's the power of comprehensions, and it seems to be a little bit more readable for me because I can see what the expression is here. I can get the variable name, and then I see what I'm iterating over, and it's got square brackets, so I know that it's of type list. Okay, so we're going to talk about now our challenge. The challenge is to create a shopping list organizer Write a program that allows the user to manage their shopping list. The program should provide the following functionality: add items to the list, remove items from the shopping list, print the current shopping list, and print a slice of the shopping list based on the start and end index. So the first thing I need to do is create a shopping cart, or a shopping list, maybe call it a shopping list. And we'll say that's an empty list. The next thing I need to do is give them the ability to do, to pick the item that they want to do, right? So I'm going to do their choice. Let me get that out of my, there we go. We're going to do print add, let's see, I've got to print, give them the options. Add item, we'll say that's 1. We can say remove item. That's option number 2. Option number 3, print item. And then option number 4 is going to be, so I've got add, remove, print. Now let's do slice. And then last option, and we'll say 5 is to quit or exit. Now I've got to get their choice. So we're going to use the input method. Now I got to convert that input into an integer. So I'm going to say int. Wrap that whole thing in an int block. That's an int constructor. That's going to give me back an int. And I'm going to call this variable participant. Participant choice, and I'm going to assign it into that. Now, I'm going to go and look back on our day 2. I'm going to scroll up, and we did some challenges here where we did the if, else if. That works out, that's fine. But what I could do is go back and learn how we did, where is it? There we go, match. Remember how we did a match? And we did this case concept. Let's go ahead and do this match syntax so we can practice using some more syntax. So I'm going to match on participant choice, and then it's going to be case 1 case 1. Now I'm going to have them input an item to our shopping list. So now I've got to get their input. Item to add. Actually, yeah, and then we'll force that into that shopping list, right? So let's put this as a variable called item. Once they type it in, we're going to go ahead and append that to our shopping list. So now the shopping list has that appended item. Let's go ahead and run case 2 now. Case 2 is where I'm going to remove that item. So now I got to get item again. This time it's item to remove. Shopping list dot. And if I hit tab, remember it shows us that IntelliSense. So I'm going to go ahead and remove, and then I'm going to type in the item that they chose to remove. Okay, that's all I need for case 2. Case 3 is to print the list. So we'll say case number 3. Print shopping list there. And what I also did there, you'll notice, as soon as I start typing shopping, if I hit the tab button, it auto-completes for me as well. That's another feature that integrated development environments provide. Okay, so that's option 3. Let's do case 4. But I got them indented, so it's with the same indentions of all the other cases. This one's where they're going to do the slicing of the list. So what I need to do here is I need to get 2 items from them. I need to get the start and the stop. So we're going to say start is equal to int, and then inside that it's going to be input, and inside that it's going to be start index. Then I need to get end, and it's going to be very similar. So I'm going to copy this line of code and say end. And then what we're going to do is we're going to go ahead and print the shopping list, but I'm going to slice it with start colon end. All right, and then I'm going to do case 5 is exit, so I'm going to do break. I don't even think I need to break. I don't even think I need to do case 5. I think it'll just, let's find out. I haven't tried without default cases. So let's go ahead and run this one time. And let's make the choice of exit. Well, we got to put it in a loop, but we'll just do 5 and see what happens. Yeah, it didn't do anything. Okay. I've got to make this over and over and over again, right? Because I don't want them to only have one item in their list. So the whole thing needs to be tabbed over, and I need to create a infinite loop while true. And so now everything is part of our while loop. And at the end of everything outside of the while loop, I'm going to go ahead and do a print on the final list, right? So the final shopping list. And then I'll also print the word done. All right, now it should have a little bit more utility. Let's go ahead and add an item. Let's add grapes. Let's go ahead and print the item, just so that looks. Yep, all we got in there is grapes. Let's add another item. Let's add tomatoes. Let's add another item. Apples. Let's go ahead and remove an item. I didn't mean to add apples. And let's just print to make sure that we got it all right. And we do. We got tomatoes and grapes in there. And let's go ahead and now exit. We'll hit number 5 and exit. Oh, I forgot that that's what I needed to exit for. It's an infinite loop. If I don't do case 5, we don't have our break to get out of our infinite loop. So we'll stop our execution and we'll restart it. All right, I think I should just be able to go back up to the top. Nope, why did that not work? Oh, that's what happened. I did that all wrong. Let's just do it manually. Okay, so we're going to add an item. Grapes. We're going to add an item. Tomato. We're going to add an item. Apples. We're going to remove an item. We're going to print an item, or print the list. I should have said print the list. And then we're going to go ahead and add another item. Melon. Add another item. We got grapes, melons. Let's add the apples back. So now if I print the list, I've got 1, 2, 3, 4 items. Let's go ahead and do a slice on the items. So number 4, and we'll say the start index of 0, the end index of 2, and that should go 0, 1, 2. So it doesn't include the last one, so it's going to give us grapes and tomatoes. And there we go. We got grapes and tomato. And then we're going to go ahead and see if I fixed my program, and now we can actually exit out. And we're done, right? So hit the done, and it printed out our final list. All right, challenge number 2. This one should be a little bit easier. This says we're going to take the number, write a program that generates a list of squares of numbers from 1 to 10 using list comprehensions. So we're going to print that out. So we'll start with the print. Actually, it says we could do it in 2 lines of code. So let's create a variable called myList. And we're going to say it's going to be a list comprehension. So list comprehension, we know we have expression. We use the for keyword, then we give it a variable name, and then we say in our iterable, something that we can iterate over. So I'm going to use the word range, and we're going to say from 1, 11, 1. Actually, I can get rid of that comma 1 because that's implied. Because I want to go from 1 to 10 inclusive. If I remember, the first one is included, the last one is not included, so that's why I chose 11. So that's going to give us from 1 to 10. So now my expression is I want to square the number. So how do I take a square? Is we learned back in, was it day 2? Nope, it was day 1. All the way back in day 1. The math equations, where are those? Aha. If I want to square a number, I can do star star. So let's take our variable var star star 2. What that's going to do is it's going to take the variable var, take it to the exponential power of 2, which means I'm going to square the number. And then we're going to go ahead and print the list, my underscore list. And you'll see now I get the squares, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 16 is 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. I could do this all in 1 line of code if I just did this as a print. Let the C's close that and close that, and I can get rid of this line of code now. And do the exact same thing, and I get the results. If I want to change it to the squares from 1 to 100, I can just change my number to 101 and run the code. And now I've got the squares all the way up to 100. All right, that's it for this class. We'll see you in the module 3 for day 3.